So let's talk about the Earth and globes and then how we get all that information on maps. In this part of the lecture, we'll talk about what we mean by physical geography, and then we'll talk about the size of the Earth and how the size of the Earth was first determined, and then how the Earth spins on its axis. Let's start with physical geography. So geography is the kind of general topic that is covered in this class. And geography can be considered to have two different sides, a physical geography side and a human and cultural geography side. Both of these relate to the Earth and how we inhabit the Earth. On the physical geography side, we see things that aren't directly related to mankind, like climatology, for example. We might have some influence on the climate, but we've always had climate on Earth, and in many ways that's regardless of people's behavior. On the human cultural geography side of things, we see all the ways that people interact on the surface of the Earth. And sometimes their interactions are very much based on where they are on the Earth. One example would be population geography, where in some countries or parts of the world, people have more babies and the population is increasing, whereas in other parts of the world, the population is decreasing. And one of the great things about geography is that it's a continuum between these two, that we can look at how these things interact. And that's really the exciting part about geography. Specifically for this class, we're going to be looking at landforms on the surface of the Earth, and those would be most aligned with physical geography, and more specifically with geomorphology, which is the study of the surface of the Earth and how it changes. So let's talk about the Earth. Let's start out by talking how big is the Earth? And of course we have satellites and many other ways to make detailed measurements of the Earth now, but way back in 247 BC, they didn't have any of that. And the first person to make an estimate of the size of the Earth was this guy here, Eratosthenes. And the way that he did this estimate was he made some observations. He noted that one day of the year at this well in Syene, here's Syene here, which is where Aswan is in Egypt currently. And he noted there was a well there that one day of the year on the summer solstice, the sun shone all the way down to the bottom of this well. And he also noticed that up in Alexandria, Egypt, to the north of there, on that same day of the year, the sun did not shine directly down on this obelisk, or else it would have cast no shadow, but in fact it did cast a shadow, and he measured that angle. And that angle was about 7.2 degrees. And Columbus wasn't the first person to know the Earth was round. It was always thought by most people that the Earth was round. And 7.2 degrees would be exactly 1/50th of the way around a 360 degree globe. So he understood that distance between those two places was 1/50th of the way around the Earth. And so he estimated that distance, and he might have been a little off there, but he came up with an estimate that the Earth had a circumference, if we walked all the way around it, of about 25,000 miles. And that is just about what it is. It's just about 24,900 miles around the Earth. So he came up with a very good estimate, just kind of from this mathematical angular type estimate that he did with the sun's rays. The Earth is spinning on its axis, and we've probably all heard that. A couple of things to note about that is it's always spinning in the same direction. And we can see that on this illustration here. And that axis is not straight up and down. So if we put a top onto a table and we spun it so the top was straight up and down, there would be no tilt to the axis of spin. But the Earth has about a 23.5 degree tilt. And this 23.5 degree tilt comes into play in a lot of things, but it's the tilt of the Earth on its axis for what we want to know here. And we can also see that if we were looking down on the Earth from the North Pole, the Earth would be seen as spinning counterclockwise. It would take one day for the Earth for this portion of the Earth, let's say England here, to start here, go all the way around, and come back to the position we see once again on this. That's where our day comes from. We face towards and away from the sun during that day. So the Earth is spinning in a counterclockwise direction, And if we look at what that means when we look at it from the side, instead of looking down on the North Pole, now we're going to look at it from the side. It means the Earth is spinning where the western part of the Earth is moving towards the east. So we say the rotation is eastward. So if the sun was over here, sitting right over Africa, at a later time during the day, it would be sitting over South America. So this is, the day begins in Europe before it begins in the United States. And in the United States, it's later in the day on the East Coast than it is on the West Coast because of this direction of spin.